Okay, cool. So today is March. Yay, it's March. Spring is coming. Yay. So our objective today is going to be a translation of polynomials. Okay? So all of these graphs that we just put, these are apparent functions, are polynomials. Because polynomials are just x with a exponent of like a whole number. So all of these are polynomials, and we're just going to move these. That's all we're going to do, is we're going to take and move our parent function. So number one is an x cubed. And if I look at my notes that we took, an x cubed looks like this. So I'm going to do two different colors, okay? So I'm going to put the parent function, and then I'm going to move it, okay? So my parent function I'll put in orange. The next cube, we did that. It looks like this. 1, 2, 3. Okay. That's my parent function. That's just plain old x cubed. And then let's take that and move it. So it's going to be to the left 2. Remember, it's the opposite of the inside, but it's horizontal. And then we're going to take it down 1. So I'm going to take this orange graph, our parent function, I'm going to take it left 1, 2, and down 1. There it is. That was easy, huh? Thumbs up on that one? That was pretty easy. Okay, let's take a look at example 2. Well, first, let me put the parent function in. So again, for my notes, the parent function for x to the 4th looks like that, right? So I'm going to put that in first. Put my x to the 4th in. Okay, 2 to the 4th is 16, super steep, so I'll put it way up here. Okay, there's my parent function. And then I'm going to move it. I'm going to move it to the right 1. And then I'm going to move it down 4. And then I'll make it half as tall. So I'm going to do a shrink, half as tall, which is a vertical shrink. Okay, so it's a vertical. Okay, so let's do that. So first of all, I'm going to move it right 1 and down 4. 1, 2, 3, 4. And I'll wait for you guys to watch this second piece because everybody want everybody to watch it, okay? So on the original, I'll wait till all eyes are up here. Okay. Ready, everybody watching? So I went 1, 1, right? And then I went 2, 16. I went 1, 1, 2, 16. Let's do half that. 1, not 1, but 1, 1 half. Instead of 2, 16, let's go 2, 8. 2, because I'm going half, right? I'm going half as tall. 1, 2, 3, 4, 5, 6, 7, 8. And I know that it's symmetrical, right? So I have one here. I have one here. There it is. So it is half as tall. Looks a little wider. Doesn't it look a little wider? I mean, it's so tall, but it's still a little bit wider. Not as tall, okay. All right, turn the page. Does this seem pretty easy today? Okay. Now, we're not going to graph, we're going to write a rule. So we're going to take f of x, which is x cubed minus 3, and we're going to change it. So we're going to call it a new function. I'm going to call it g of x, okay? So I'm going to make a g of x, because it's going to be my new function, okay? So instead of f of x, call it g of x, because it's going to be new. We're going to change it, okay? So how are we going to change it? Well, first, we're going to take it 4 units to the right, okay? So we have to go the opposite. If you're right or left, it's the opposite of the inside. So I'm going to take this x inside, opposite, inside, and I'm going to go 4 to the right. So I'm going to go minus 4. So I went minus 4 on the inside. I took inside of here, and I went minus 4, cubed, my bad. Then I'm going to take it 2 up, okay? So I'm going to take it 2 up. So I'm going to take this negative 3, and I'm going to go up 2. Okay, so I'm going to go plus 2, okay? And then finally, I'm going to stretch it by 3, okay? So then, to stretch by 3, I'm going to put a 3 right here. Let me simplify what I have. G of x is equal to 3, x minus 4 cubed minus 1. That's my new function. So I took this one, I moved it over 4, moved it up 2, and then I stretched it by 3, okay? Okay, let's take a look at example 4, and I'll be done. Okay, fx is x to the 5th, okay? We're going to horizontally stretch it, and then by 2, and then we're going to reflect it over the x-axis. So let's see what's going on. So anything on the inside is always the opposite. Anything horizontal is always going to be, we've learned this, horizontal is going to be on the inside and opposite, okay? And then reflect it over the x-axis. Let's see. We're going to make the y's negative. So reflect over the x-axis, right? We're going to make the y negative. What does that mean? Well, I'll get you there. Okay, I'll get you there. So let's call this g of x because it's brand new. It's not the same function. It's called g of x, not f of x, but g of x. Okay, first of all, I'm going to do this. So I'm going to go parentheses. So if I'm going to stretch by 2, it's the opposite. I'm going to go 1/2. I know that seems just so different, but if you put the 1/2 here, x to the 5th, that does stretch it, makes it wider, okay? And then the next thing I'm going to do is make the y negative. So if I make the y negative, if I make this negative, that really, I'm going to bring it over and go g of x is equal to a negative parentheses 1/2 x to the 5th. That's a little bit harder. So some of this stuff, the good news, you can just do with your decimals, right? But some of it you're going to actually have to make the equation. Decimals won't do that for you, okay? But we've got plenty of time to get this done. You know, if they go to 42, they're talking about